Quick question. A test for a rare disease is 99% accurate. Someone takes it and it comes back positive. What are the odds they actually have the disease? Most people's gut answer is 99%. The real answer is usually far lower than that. And the gap between those two numbers has a name. It's called the base rate fallacy. And once you start running a business off your own numbers, you run into it constantly, whether you know its name or not. I'm not a statistician and I don't have a data science team sitting behind me. I run my own businesses off spreadsheets, dashboards, and the same kind of alerts anyone running a small operation ends up staring at every week. Churn flags, fraud warnings, split test results. Nobody hands me a clean answer. I'm the one who has to look at the dashboard and decide whether to act, and I've made the mistake this whole video is about more than once, trusted a number because it sounded confident and gotten it wrong. So think of this less as a lecture and more as a warning from someone who's paid for not thinking about it carefully enough. The base rate fallacy is what happens when you judge how likely something is based on one piece of evidence right in front of you, while ignoring how common that thing actually was to begin with. The base rate is just that starting frequency, how often something happens in general before you look at any specific case. It sounds obvious once you say it out loud. It's very easy to forget in the moment, which is exactly why it keeps catching smart, careful people off guard. Go back to that disease test. Say only 1 in 10,000 people actually have the disease. That's the base rate, and it matters enormously. Even a test that's 99% accurate is going to flag a lot of healthy people by mistake, simply because there are so many more healthy people than sick ones to begin with. Run the actual numbers, and a positive result might mean less than a 1% chance of really having the disease, even though the test itself is 99% accurate. That gap between what a result feels like it's telling you and what it's actually telling you is the base rate fallacy in a single example. Part of why this trips us up is that our gut just isn't built to hold two numbers in mind at once. We hear 99% accurate and we lock onto that figure because it's the one that was said out loud to us. The fact that the disease itself is rare almost never gets weighed at the same time, even though it's doing just as much work in the actual answer. That's not a character flaw. It's just how intuition handles this kind of problem, and it means you have to catch it on purpose every time because it will not catch itself. In That's dataresearchanalysiscollection, that disease example is about medicine, but the shape of it shows up everywhere you look at a number and decide whether to act on it. Most of the alerts, models, and metrics you check day to day as a solo operator are exactly this kind of test in disguise. Something rare is being flagged by an imperfect tool, and the instinct is always to trust the specific alert sitting in front of you instead of asking how common the underlying event actually is across your whole base. When I look at a churn flag, a fraud alert, or a funnel report, I'm the one deciding whether to act on it. There's no analyst sitting between me and that decision. No second pair of eyes to slow me down. That's exactly the setup where this fallacy is most dangerous, because nobody is pausing to ask, across my whole customer base, how common is this event really? And does that change what this specific alert actually means? 3 places this bites solo operators the hardest, in my experience: churn prediction, fraud and spam detection, and reading split test results when your baseline conversion rate is small to begin with. All 3 have the same underlying trap, wearing a different costume, and all 3 are worth walking through on their own, because the fix looks slightly different each time. And with churn, say you build or buy a model that flags customers as high risk of canceling next month, and is right 90% of the time when it says someone's going to churn. That sounds solid on its own. 90% right sounds like a number you can just trust and act on without thinking twice. But say only 3% of your customers actually churn in a given month. Look at what that means across, say, 1,000 customers. Roughly 30 of them will genuinely churn. Your model catches most of those 30, which is genuinely useful. But it's also going to falsely flag a chunk of the other 970 who are never leaving at all. Depending on how the model's false positive rate shakes out, the number of people wrongly flagged as high risk can end up close to or even higher than the number of people who are genuinely at risk. The theoretical effect is this. You get a list labeled high churn risk, and you'd be wrong to treat every single name on that list as someone about to walk out the door. A real share of that list is healthy, happy customers who just happen to look risky by whatever pattern the model keys on. Use that list to justify a discount, a win-back email, or a personal phone call, and you're spending time and goodwill on people who were never leaving in the first place, and you might even annoy them by implying they were about to churn when they weren't. None of this means churn models are useless. It means the base rate, how rare churn actually is across your base, has to be part of how you read the output, not an afterthought bolted on after the fact. A flag is a reason to prioritize a look. It is not a verdict, and treating it like one is where the trouble starts, usually quietly, over months of small wasted gestures. Fraud and spam filters run on the exact same math, just with a different label stuck on the front of it. Genuine bad actors are a small slice of your total traffic, even on a bad day. So even a filter with a low false positive rate is going to catch a meaningful number of real customers in its net, simply because real customers massively outnumber fraudsters to begin with. If you've ever had a customer complain that their card got declined or their account got flagged for suspicious activity when they did absolutely nothing wrong, this is usually why. The filter isn't broken. The base rate of fraud is low enough that even a filter tuned with real care is still going to produce genuine false positives relative to the small number of true positives it actually catches. Knowing that changes how you set the thing in the first place. Tightening it to catch one more fraudster might cost you several legitimate paying customers, and that trade only makes sense once you've actually looked at your real fraud rate instead of just assuming one out of instinct. The split test case is subtler, and it's the one that catches people who already think they've learned this lesson somewhere else. If your baseline conversion rate is low, say a landing page converts at 1 or 2%, then a test run for a few days on modest traffic is working with a small base rate of the one event you actually care about, an actual conversion, not the click, not the visit. Small numbers of successes swing around a lot by chance alone, the same way flipping a coin 10 times can easily land 7 heads without the coin being biased at all. A variant that looks like it's beating the original by 30% might just be noise, because the base rate of conversion was never high enough for that sample size to say anything confident either way. This version of the fallacy isn't about a diagnostic test anymore. It's about mistaking a small noisy sample for a confident settled readout. The fix here isn't some formula you need to memorize, it's a habit. Before you trust a lift number, ask how many actual conversions the test was built on, not visitors, not clicks, conversions. A lift built on 12 conversions per arm is telling you a completely different story than one built on 400, even if the headline percentage looks identical on a slide. So how do you protect yourself against all of this without going back to school for a statistics degree? A few habits do most of the work, and none of them require memorizing a formula. First, before trusting any specific alert, ask how common this event actually is across your whole base to begin with. If churn, fraud, or conversions are rare where you operate, expect any imperfect signal to produce more false alarms than your gut assumes it will. Second, look for the raw counts, not just the headline rate. 90% accurate tells you almost nothing on its own, no matter how confident it sounds. Out of everyone flagged this month, how many actually turned out to be real? That's the number that tells you what you actually need to know. If your tools don't show you that breakdown, it's worth asking for it directly, or pulling a sample and counting it yourself by hand. Third, treat flags as a shortlist, not a verdict. A churn flag, a fraud flag, a winning split test variant. All of these are a reason to look closer, not a fact to act on immediately, especially when the underlying event is rare to begin with and the tool is working off limited signal. Fourth, be skeptical of exciting sounding case studies and single standout results, yours or anyone else's. One anecdote or one great week tells you almost nothing about the base rate it actually came from. That's true of a glowing customer testimonial someone sends you unprompted. And it's just as true of your own best result ever. The week you want to believe is the new normal. None of this makes churn models, fraud filters, or split tests useless, and I'm not telling you to throw any of them out. They're still better than guessing blind, and I still use all three in my own businesses. But a metric or a flag is only as trustworthy as your understanding of what it's actually being measured against. And the base rate is usually the piece that's missing when a number feels more confident than it honestly deserves to. I don't treat any single number as the whole picture, and I wouldn't be doing you any favors if I stood here and told you a model or a test result was a substitute for actually looking at what's going on with your own customers. The number is a starting point for judgment. It was never meant to replace it, and the moment you let it, that's the moment it starts costing you. Every one of these explainers lives in writing too, at dataresearchanalysiscollection.com. The whole metric library laid out in plain English, no jargon, no hype, and no invented numbers dressed up as proof. Every metric I've talked about here is explained in writing at dataresearchanalysiscollection.com. So if this was useful to you, go ahead and hit subscribe for the next one.